Hi, this is a session on construction materials. Uh, this is third session, characteristics of good building stones and requirement of building stones. In the previous session, we have studied the different characteristic, classification of the zones, different types of zones, how the stone forms, stone cycle and all. In this session, we are going to learn about the characteristics of good building stones and the selection of the good building stones and all. Let us see, as usual, before starting any session, we see what are the outcomes for that particular session. Let us see the outcomes for this particular session. At the end of the session, learners will be able to, number one, understand vital characteristics, requirements of a good building stones, and select the right stone for the right work. So as an engineer, you must be aware that stones which are good in some characteristics may not be good in some other characteristics. For example, if a stone is very good, very strengthy, very non-porous, very impermeable stone and very nice stone, you can say, but when the same stone is not good while dressing it, while making it into a desired shape, then the problem arises. That is why an engineer should be sole responsible to choose the right stone which has the desirable characteristics and requirements. So basically the characteristic is nothing but the stone is having different characteristics. That is like, for example, stone is having specific gravity from 2.3 to 2.7, whereas that is a characteristic of a stone. Specific gravity may fall in that particular range, but the requirement for a particular project may be like stone specific gravity should be more than 2.7. In that cases, that kind of things, that requirement comes, and the character is nothing but what its character inhibits in general, in generic view. So that is how these takeaways we are going to take in the at the end of this session. Let us see the different parameters involved, different characteristics involved, and that character, what is our requirement as an engineer, is a most important necessary. So first characteristic is or first requirement is a high strength. High strength is a vital requirement for any stone. Generally what will happen, stones are generally will be having a good compressive strength, but the tensile strength, bending strength and impact strengths will be very less for the stone as well as concrete too. So high strength is nothing but it is an ability of the material, any material, to resist the failure under the action of stresses. So it is ability of the stone to resist failure under the action of stresses caused by the loads, the most common being compression load, tension load, bending and impact strengths. Stones, as I told you, stones and concrete have a very high compressive strength, but very low, that is 1/5 to 1/50th low tensile, bending and impact strengths. So stone is good at compression strength. Compressive strength is nothing but load is applied on both the side, from bottom as well as from top. That is compressive strength. Tensile strength is nothing but the material is pulled, the direction of the force is in the opposite direction, that is said to be tensile strength. Bending strength is nothing but the stone is made stone or any material is made on to stand on in between two supports, and the load is given at the center or at any point of the span. That is bending, whether it is able to bend or not, that is a bending strength. Impact strength is nothing but the sudden application of the energy, sudden application of the load creates an impact on the material, that is said to be impact strength. So these are the different strengths. Anyways, you are going to learn it in subsequent semesters. Compressive strength is a very high in stone. Generally it will be high in all the stones. Generally compressive strengths will not be tested for construction of the general works, but when it is very necessary to know heavy structures, then you need to go for the compressive strength checking. Compressive strength is found from the tests on standard cylinders, prisms, cubes, etc. So these are the compressive strength will be found from the tests of cylinders. Small cylinders will be done for a specified measurement, prisms will be done and cubes will be done. That specimen is kept under the compressive testing machine. Then that machine will give the load and that load, what is a maximum load it can take before failure will be noted down, and that is compressive strength, compressive load. That load divided by area on which the cube has been tested. The area, it may be, if it's a cylinder, the area will be pi r square or pi d square by 4. Prism, the area will be different, cubes, the area will be different. That area is divided and you will get the compressive strength. That will be studied later on. Smaller for homogeneous materials, the compressive strength will be very small for the homogeneous materials, and larger for the less homogeneous material. Less homogeneous means it's a composite material. Then a lot of materials together will call composite material. These composite material will be having high compressive strength, like even concrete, and even stone is also a composite, because of lot many minerals together will form a one particular body that is called as stone. So that is high strength. As I told you, compressive strength of a building stones generally fall within the range. See, you can see here, within the range of 60 MPa. MPa means megapascal, to 200 MPa, or you can say Newton per mm square. Both are same, 60 to 200 Newton per mm square. That is a compressive strength of any general stone. One should choose stones based on the strength requirement of the project. See, this is a 60 to 200 MPa. Is a compressive strength of a stone. That is a characteristic of a stone. But the requirement of the stone, the requirement, strength requirement of the stone may be 100 MPa or even 150 MPa or even 200 MPa. That is based on the project. If the project is having high load carrying capacity, then you need to have a higher good quality, I mean good strength stone, that you have to choose either 100 and above, and even 200 and 200 MPa itself. But in general, the stones should not have, should be more than 100 Newton per mm square. The strength compressive strength of the stone should go above 150 or even 100 MPa, 100 Newton per mm square. Then that strength of the stone is a good requirement for our any projects. Generally you can use 100 MPa and above. So that is strength. Next one is less water absorption. So the general requirement for the construction, the water absorption by the stone should be less. It means stone should absorb the water very less, like 0.05% or 0.005%, that kind of percentage. It should not go high. So requirement is less water absorption, and characteristic is water absorption. Stone will absorb the water. That is a characteristic of a stone. But our requirement is less water absorption. That is the difference between requirement and characteristics. So stone is going to absorb water. That is a characteristic of a stone. Whereas stone should absorb less water for our construction works. That is said to be a requirement of a stone, good building stone. It denotes the ability of the stone to absorb and retain the water in its body. It is expressed as a percentage in the weight or of volume of dry material. So it is expressed a percentage of weight. For example, we have a 1 kg of stone, and that stone is merged into water, submerged into water for a period specified in as per IS codes. Then that will absorb certain quantity of water. After a period of time, so let's say 24 hours, you are going to remove it from the water, then wipe the surface of the stone, then measure it. Before putting into the water, you have to measure it a dry weight. After putting into water, you are going to measure it as a saturated weight. And so saturated weight minus dry weight, you will get the water present in the body of the stone. Then that water divided by dry weight into 100, you will get the percentage of water absorption by the stone. So that is a very much important essential parameter, or even say characteristic for the stone, which we need to consider while choosing the best quality of stone in the construction. Water absorption of stone is directly proportional to the porosity of the rock. If the stone is more porous, then it will absorb more water and cause more damage to the stone. So The water absorption of a stone is directly proportional to the porosity of the rock. It means the porosity is nothing but pores present in the body of the rock, or say stone. If the pores are more, then the surface area will increase. If the surface area is more, then the absorption will increase. This absorption, if it is high, then what will happen? Stone will absorb more water and deteriorate and damage the stone. So lesser the porous, very good the absorption value. Very good means it should be lesser. So in higher altitudes, like even in your in case of Himalayas, or in case of any Western countries where there is a lot of icebergs and all, in those cases what will happen? There is a chances of icebergs and freezing of water. It will freezes to a temperature of around 0 degrees centigrade. In those cases, what will happen? The pores present in the body of the stone will absorb certain quantity of water, and that will fill up with the water. Then in the freezing point, that will become it will become frozen. Water will become frozen. Then that particular pore will get wider, and eventually it will result into disintegration of the stone. Stone will become disintegration. Disintegration means breaks. It breaks. Disintegration will take place. That is how it happens in higher altitude. Higher altitude means generally the high atmosphere with a cooling temperature. Higher the water absorption, stone is more susceptible to the stains. This is very much important point. You may get this question in even exams also, like competitive exams and all. Which is a characteristic of a stone which makes, or which is parameter where we can find whether the stone is going to be stained or not. Stain is nothing but the mark or a patch mark on a stone of other material. Like for example, whenever you go into ice cream parlor, if you take ice cream, if suddenly the part of the ice cream falls on your white shirt, what will happen? That white shirt will be connected with some patch. That patch is a stain. That stain can happen even for stones also. This stain will happen due to the indicator for the stain is before construction. You can find out whether the stone is going to get stains or not. That is by the value of water absorption. If the water absorption value is more, it is higher the water absorption, stone is more susceptible or more vulnerable to get stains. So generally we have to select the less water absorption of the stones, then the stains will not be there. So that is second point, that is less water absorption. That is one of the requirement of our building stones. So the characteristic is absorption of stone. Stone will absorb the water. Absorption of water by the stone, that is a characteristic. Less absorption of water is a requirement for any good building materials. So in this point we have discussed how higher altitude, what causes the disintegration of the stone. That is because of the frozen water in the pores, and stone will be more susceptible to stains if the water absorption is more. So water absorption is nothing but so body of the water, body of the stone will absorb certain quantity of water and it retains in the body, and that is expressed in terms of percentage. The third one is durability. So as the word itself will indicate you, durability means the ability of the materials to resist the combined effect of the atmospheric and other factors. Ability of the material to resist the combined effect of atmospheric and other factors, that is said to be durability. Durability is nothing but it's the lifespan of the stone before losing its serviceability. So building stones should be capable to resist the adverse effects of the natural forces like wind, rain and heat. So building stones should be capable to resist the adverse effects of natural forces, natural items like wind, rain and heat. It must be durable and should not deteriorate due to the adverse effects of the natural forces. So stone should be very good resistant to all the atmospheric agencies like wind, rain, heat, and other frost, etc. So as long as these parameters the stone is able to resist, then that is durable. So durability is nothing but it's an indicator where the stone is able to resist the combined effects of the atmospheric and other parameters. So you can see in this picture there is a stone which has been disintegrated here because of the atmospheric effects, like it may be wind, maybe rain, or it may be frost, or it may be even any atmospheric agencies. What has happened here is this is the width of the your plastering, or you can say bonding. This bonding has been came out here, and the stone has been fell down pieces by pieces, that is disintegrated, that has been taken a physical damage like wear and tear, and this is how that stone has been deteriorated. That is said to be a durability. That is said to be this stone is not a durable. So hardness and toughness, this is one more important parameter where we can find the characteristics of the stone as well as our requirement also we can discuss here. Hardness is an ability of the material to resist the penetration by the harder bodies. Ability of the material to resist the penetration of the by the harder bodies. So Mohs scale is used to find the hardness of the material. So Mohs scale, there are two things in civil engineering: Mohs scale and Morse circle. Morse circle is generally used to find out the stresses, that is in strength of materials, but here it's a Mohs scale. Mohs scale is used to find out the hardness of the materials. So what is hardness? Hardness is the ability of the material to resist or withstand the penetration by the even harder bodies. Suppose say if you have a piece of butter, and if you take your finger and penetrate into it, because the butter has got a very soft, it is not harder, much harder. Similarly, if you take a talc powder or talc ball and you can put your finger, you can see its hardness. Similarly, you can't take a piece of metal and put your finger and scratch it, because metal, or you can say iron, is most harder than our finger. So that is how the resistance of the material for the penetration by the harder bodies is said to be hardness. Okay, for this Mohs scale is used to find the hardness of material. It is Mohs scale is nothing but it is a list of 10 different minerals arranged in order to increase in the order of increasing hardness. 10 increasing hardness, you have put the different minerals so that it will give the hardness, the equivalent hardnesses. Hardness of metals and plastics is found by indentation of the steel balls. So hardness of metals and plastics is found by the indentation of the steel balls. So the one more word, equivalent word, is toughness. There are two different things. Hardness is what you understood now. It is resistance to the penetration. Toughness is different. Toughness is the measure of impact that a stone can withstand, is defined as toughness. So it's a measure of impact, sudden application of energy on a material or stone, which can withstand it by the stone, is said to be toughness. Whereas hardness is different. It is not sudden application of material. It's just penetration, slow penetration. So that is the penetration's hardness. Then toughness is a measure of impact that stone can withstand the that is said to be a toughness. The stone used should be tough when vibratory or moving loads are anticipated. The stones used should be tough when vibratory or moving loads are anticipated. When there is a vibration nearby during industrial shed construction and all, you need to have that very tough stone, because there is chance of vibrations generation at the your factory. In that case, you have to use a very tough stone to resist that particular parameter. So that is hardness and toughness. So the general character is stone is harder and tough. Our requirement is stone should be much harder and tough. So based on the different Mohs scale, we are going to find the best suited stone, and then eventually we are going to select that particular stone for our construction works. This is Mohs scale. in this Mohs scale you can see the mineral is arranged like this, then the scale number is given, then common objects are given to test. So in the increasing order, from bottom is a low and at the top is a high. So this is soft material, soft, and then it will become at the diamond, it will become harder material. Number 1 Mohs scale indicates the less harder. Number 10 indicates the more harder. So you can see talc, gypsum, then calcite, fluorite, apatite, orthoclase, quartz, topaz, then corundum, then diamond. These are the different minerals. So numbers are given here. Up to 2.5 harder material, you can use your finger, scratch on the material, you will get to know the material is having Mohs scale value of around 2.5. Suppose say if you take a Vibhuti and scratch on it, it will eventually, what will happen? The powder will come up. It means the Mohs scale number is less than 2.5. Similarly, if you take a copper penny, it means a coin, any coin, and scratch on the surface, what will happen? The value for that particular, if it's getting powdered, then that is value is 3.5. Similarly, little more, like up to 5.5, you should use knife or glass piece to cut or scratch on the material like wood and all. It will be having a small scale of 5.5. Steel nails, like concrete walls also, you can, some brick walls also you can give the steel nails. Steel nails, if it is able to penetrate into the body or scratch on the body, then that is said to be 6.5. The Mohs scale value is 6.5. If it is not able to penetrated by the steel nail also, then you have to use the drill bit. It means you will be having drilling machine. In that, drill bits are there at different diameters. If you supposed to use a drill bit, it means the Mohs scale value is 8.5 and above. So Mohs scale value is indicator for the whether the material is harder or not. So up to 8.5 you can use these materials. After 8.5 you have to use the drilling bits of different diameters for the for checking the hardness. So this is the Mohs scale. Based on this, you have to select the rocks. These are the different. This is talc, this is fluorite, quartz, then you have corundum, etc. So next one is dressing. As you are already aware of the word dressing, why we usually wear dress? Dress is to get a pleasant appearance for the appearance, as well as to make our life comfortable and we feel comfortable in the good dresses. The same thing is valid for our stones also. Stone should good look, and stone should give an aesthetic effect to the building. That is why we are going to make a uneven shape stone into a even shape, required desired shape of stone. That is said to be dressing. Giving a required shape to the stone is called as dressing. It should be easy to dress so that cost of the dressing is reduced. So the cost of the dressing should be reduced. So you have to use such kind of dressing designs and all. However, the care should be taken so that this is not to be at the cost of compromise in the required strength and durability. So we should not compromise in strength and durability, but you have to choose a good stone which can be dressed well. So that is dressing. Dressing means, you can see here in this picture, this is dressed stone. It's not just boulder. Boulder means it will not be having this kind of shape and all. They have made here dressed here properly so that it can look good and make a good masonry wall. So that is one thing. Next one is cost. Cost is an important requirement in selecting building materials. So the cost is generally controlled by what? It is controlled by the transportation cost. If the transportation of the material or stone is more, transportation cost is more, obviously that will impact on the cost of the stone. Suppose if you want to choose a building stone at Bangalore, suppose say at KR Circle nearby Vidhan Soda, if you want a building stone, that stone should come from outskirts of the Bangalore or even from some other cities. So that cost of travel of transportation of the material from that place to here will cost you so many rupees. If you are constructing your house somewhere nearby quarry, then the cost will be transportation cost will be less. Eventually that will affect on the material cost. This is also important parameter. Apart from this, the different choices of the stone will also impact on the cost. Like granite has got different cost. Even in the granite itself you have different variations, and in marble also you have different variations. All the variations will have different cost. Then you have different materials like marble and all will cost you more than the some other materials like basalt and all. So, and kadapa tiles and all these things. These parameters impact the cost of the material, selection of the cost of the material. The requirement is based on the cost also. If a person is having less a budget for the particular building, he is not going to have a requirement of good polished marble stones on that particular floor. So you have to choose choose the best quality in the desired budget. So that is a cost factor. Then you have one more important parameter that is called as density. The density of the stone should be very high. That is a requirement of any good building stone. And density, every stone will be having a density, that is a general characteristics of the stone. The density of a unit volume of stone is denoted by rho equal to m by v. Density of different stones varies. Density of widely used granite is about 2.6 grams per centimeter cube. So the next one is important parameter that is called as specific gravity. This specific gravity word you are going to listen in up to your final semester, because specific gravity is very much important parameter or characteristic of any building material. Let us say wood or stone, or it may be concrete, or it may be cement, or it may be sand, whatever it may be. Every material has got a specific gravity, and that specific gravity is utilized in civil engineering technologies. So you need to learn specific gravity definition first and understand the definition of the specific gravity. Then you have to eventually see what is this specific gravity happens. I'll give an example. If you are able to have 1 kg of cotton and 1 kg of steel, how it will feel? Both will weigh same, but the your metal steel is having a less volume, and your cotton has got a high volume. That is because of specific gravity difference in specific gravity. Similarly, if you take a ball of butter, put into water, what will happen? The butter will come up and water will be just below. Butter can flow on the water surface. Even in ice also, ice and water, if you take ice cube will come and stand on the flow on the surface of the water. That is because of the difference in specific gravity. So specific gravity is a very important essential parameter in designing concrete mixes. In designing specific gravity of stone is important for designing the concrete mixes. Higher the specific gravity, more strength of the stone will be there, and lower the specific gravity, strength of the stone will be less. So specific gravity calculation and all determination of material will be studied in the material testing lab, that we can discuss later. So you can see here, higher the specific gravity, higher the strength, as we told you. The specific gravity of stone varies between 2.3 to 2.7. Again, it depends on the type of the stone. Even it may be little bit here and there, but our requirement is the specific gravity of the stone should be high, then only it is going to have a good strength. 2.65, even 2.7 is also okay. So 2.7 and above is a very good specific gravity. So specific gravity of the stone is found out again by using a dipping bucket type. Stone is immersed over a period of time and then tested. So that will study it in the material testing lab, as I already told you. The next important parameter is porosity. Porosity is nothing but it is the ratio of tiny open spaces, tiny open pores present in the stone to its overall solid volume. Tiny open spaces present in the entire body of the stone divided by the total volume of the stone is said to be porosity. Fluids are transmitted by the pores and capillary structures they build within something, in this case stone. So fluids like water and gases will fill these pores and capillary structures present in the body of the stone, and that will eventually disintegrate the stone. Therefore, if the material is porous and permeable, it is more able to absorb the liquids and other materials. If the stone is having more porous, then it will absorb more water. So more water or any other fluids, eventually in case of water, if it absorbs more water, then eventually the stone is going to be disintegrated and deteriorated. So that is number 9, porosity. Number 10, appearance. For a face work, it should have fine compact texture. Light colored stone is preferred, as the dark if you choose a dark color, the colors is likely to fade due to the atmospheric agencies like sun, rain, or even frost action, wind, etc. So you have to choose a light colored stone against the dark colored stone. So stone should have a fine compact texture, so that there should not be any against acting, or you can say disintegration of the stones. So stone appearance is very much essential when it comes to face works like masonry works. You need to give a good appearance of the structure. So that is appearance of the structure. Then the next one is texture. A broken stone should not be dull in appearance and should have a uniform texture. Uniform texture means the particles, arrangement of the particles should have a uniform, that is said to be texture. A broken stone should not be dull in appearance and should have a uniform structure. If you break a stone which is required for the structure, you can see the arrangement of the particles on the stone section. It should be uniform in nature. So it should not look dull. Dull means there should not be variation in the texture. That is not good stone. So the requirement is it should have a uniform texture. So the stone should be free from the cavities. It should not be having any cavities like holes and all. It should not be having a cracks on the surface of the stone, and stone should not be having patches of the loose or soft materials. So stone should not having any loose or soft materials patches on the surface of the stone. That is how the texture should be arranged. Stratification should not be visible to the naked eyes. Stratification is nothing but when you have a foliated rocks like your sedimentary rocks and all, that will be having a layers. That layers will be there in all the rocks if it is used by the your sedimentary rocks. That layers, or you can say stratification, should not be visible directly to the naked eyes. That is how you need to choose a good stone. Workability. So the next important parameter is workability. So you buy a good stone, it will be having very good strength, good durability, and it is not breakable and all. But the thing is, if you are not able to dress it, if you are not able to lift it to the masonry wall, then that is not workable. You can't use that work. You can't use that particular stone for the construction, because you need to shape the stone. You need to give a perfect size to the stone. Then only you can use the stone. So that is why workability is nothing but stone should be workable, so that cutting, dressing, and bringing it out in the required shape and size may not be uneconomical. So when you choose a stone, while choosing, you need to aware that the cutting and making it to the desired shape and size should not cost you more than the stone cost. That stone is not workable then. So you have to choose a proper stone which is having good strength, good durability, good workability, where you can easily place, where you can easily dress it, where you can easily make a required desired shape. So that is workable stone. So here in this picture you can see a person is chiseling the stone. He's easily able to make a corners and edges and he can easily make a shape to the this particular stone. It means the stone is workable here. Fire resistance. So here two things are there. One is fire resistance, other is thermal resistance. Fire resistance is nothing but when the fire is directly intact with the stone, that is fire resistance. When fire is not directly intact with the stone, but only its thermal waves like heat is connecting to the stone, that is thermal resistance. Now we will discuss fire resistance. Stones should be free from the calcium carbonates, oxides of the iron, minerals having different coefficients of thermal expansion. So whatever stone you use for the construction or building should be free from the minerals which have different coefficient of thermal expansion. Like suppose say calcium carbonate, oxides of the iron and minerals are having different coefficient of thermal expansion. If all these minerals are together forms a stone, then that stone, if it is exposed to certain fire, then what will happen? Some minerals will expand, some minerals will contract. Eventually the stone is disintegrated. If all the minerals present in that particular stone are of same thermal expansion coefficient, then there is no chances of breakage. So while choosing this, we need to keep in mind igneous rocks show a marked disintegration principally because of quartz present in the igneous rock, which disintegrates into a small particles at a temperature of about 575 degrees and above. When you expose igneous rock into a temperature of about 575 degrees and above, what will happen? The quartz present in the quartz mineral present in the igneous rock will disintegrate and becomes a small particles. Eventually the entire stone will disintegrate. That is at a degree of 575 degrees centigrade. Whereas limestone, however, can withstand a light higher temperature, even more than the igneous rock. It can sustain a temperature of about 800 degrees centigrade, after which they can disintegrate and become smaller particles. So that is limestone and igneous rock. So you have to choose a right stone for your right work, so that if your stone is directly connecting to the heat then or fire, then you have to choose a little good quality like limestone and above quality material stone, so that it can withstand the fire. So the next important parameter is equally I discussed thermal movement. Thermal movement alone are not usually troublesome or hardsome to the stone, but when marble slabs show a distinct distortion when subjected to heat. So when it is subjected to certain heat, the marbles will show a distinct distortion because of presence of the huge quantity of parts, which will disintegrate and becomes the particles, smaller particles. An exposure of one side of the marble slab to heat may cause other side to expand and the slab wraps. On a cooling, the slab does not go back to its original shape. If you are having a slab of marble, if you heat certain marble at one side, it will wrap. Eventually what will happen? It will fold. Then on cooling also it will not come to the original shape. It means marble is more susceptible to the thermal movement. The temperature can wrap the marble slabs. So that is how you have to choose. If you are using a kitchen slab and all, there is a chances of thermal heat exchange. Then you have to use the other material like granite slabs or even kadapa slabs and all, but not the marble slab, because marble can wrap, change its shape when it's applied with a certain quantity of heat. So eventually if you have a good burner and good stove spacing between the stove and the slab, then that may not be the problem. But in kitchen slab and all, you may not use marble slabs because it can easily wrap. These parameters are very much important and essential part of the selection of any materials for the construction works. So thermal movement, I think I made a sense here. Thermal movement is nothing but the movement of the heat waves applied on the surface of the material like stone and all. That is a thermal movement. Fire resistance means direct application of the fire on the surface of the stone is a fire resistant. Fire application. The stone should be fire resistant and it should be should give a good thermal movement based on its thermal coefficients. So that is how we need to choose. So we are coming to the end of the session. So before, as earlier, even your before session also we have done, we have known two outcomes for this particular session. At the end of this session, as I told you, learners will be able to understand the characteristics and requirements of the good building stones. And the second one is they can choose the better stones for their construction work. Right stone for right work. As I said, you granite for this tiles as well as even for kitchen slabs also. Based on these parameters, we have to choose the right work. Let us see the outcomes were achieved or not by using a assessment tool that is called multiple choice questions. Let me take you through first question. For a good building stone, what is required crushing strength? For a good building stone, what is required crushing strength? Less than 50 Newton per mm square, greater than 100 Newton per mm square, 155 Newton per mm square, net 10 Newton per mm square. See, let us see which is first. In answering your multiple choice question, you should be able to omit the wrong answers so that the right answer will be left out at the last. Let us see, let us come from the bottom. 10 Newton per mm square, is this the answer? No, because 10 Newton per mm square is a very less strength. Stones will have a strength between 60 to 200 Newton per mm square. That is what we have studied. 155 Newton per mm square, maybe this is the answer. Less than, greater than 100 Newton per mm square, maybe this is also an answer. Less than 50 Newton per mm square, no, this is not answer, because 60 to 200 is what our general definition. So we have stuck up with answer B and C. Greater than 100 Newton per mm square is a requirement of a stone. 155 Newton per mm square. See, for a good building stone, what is the required crushing strength? 155 Newton per mm square is also a strength which is desirable for the stone. Greater than 100 Newton per mm square is also a desired strength. But which one you are going to choose now? If I choose greater than 100 Newton per mm square, then 155 also I have covered there. Okay, so that is why the best quality stone we should have greater than 100 Newton per mm square. It may be 155, 160, 110, 105, whatever it may be. It should be more than 100 MPa. So the right answer will be answer B, that is greater than 100 Newton per mm square. The next question we will discuss, which of the following is a good fire resistant stone? Out of which clay, granite, quartz and limestone. As we have studied, let us start from the bottom again. Limestone can withstand a temperature of about 800 degrees centigrade. Quartz, as we have discussed, quartz with a certain temperature, even 575 degrees centigrade, quartz will become a particle and it will eventually fall down. That is, quartz is not the answer. Limestone may be answer, but it is only 800 degrees centigrade. Granite may not be so much height, temperature like granite will also resist the temperature. And the first one is clay. Clay may be the answer, because whenever you see Pizza Hut and some roti, tandoori curry, and wherever you go, tandoor roti and all will be burnt on the clay chula. Clay chula means even if you see rural areas and all, chulas are there, like walegalu, what you say, those chulas were constructed with the help of a clay, fine clay. This clay has got a very good fire resistant. Fire can directly act on the clay. Clay will become harder and harder, but not disintegrates. So clay is what the right answer, that is clay. Clay can withstand more fire. Eventually the smaller particles together forms a rock, and if it disintegrates it will become clay. Hence clay is also a stone. So third one is, what is required specific gravity for a good building stone? Greater than or equal to 2.7 may be the answer. Less than 3 may not be an answer. Some of the stones may be even more than 3, because if you see aluminium ores, hematite and magnetite, iron ores, which have got very high specific gravity, even 3.5, 3.6 also, those will be having more high specific gravity. Hence you can use specific those aggregates also for certain kind of concretes. So that we can't deny here. Less than 3 may not be the answer. Greater than 3 is obviously there is no range, because it may not fall exactly on those. Even general category of rocks, less than 2.5 may not be the answer, because it will not be less than 2.3 and all. So 1 is less than 2.5, so answer may not be D. It is the answer may be up about, we can give an answer of about 2.7. Up about 2.7, it means 2.6 to 2.7, 2.8, somewhere there. In Bangalore, the aggregate or wherever zones surrounding the Bangalore have 2.6 to 2.7. Generally, it will fall in this category. Even more for other ores, like what I told, iron ores, hematite, magnetites, and all, you will get even more specific gravity, but generally that is not used everywhere as a stone for a building construction. That is used for certain specialized concretes. So what texture should a building stone possess? Texture: loosely grains, crystalline structure, cavities, cracks. Loosely grains is not a characteristics or requirement of a stone. Cavities should not be there at the stone. Crack should not be there. That answer must be B, that is crystalline structure. Crystalline stone should have a crystalline structure so that it can have a good strength. Fifth one is dolomite is a bicarbonate of dash and dash mineral: magnesium and aluminium, calcium and aluminium, magnesium and calcium, sodium and aluminium. The answer is number C, that is magnesium and calcium. So dolomite. Number 6, which factor is a character of a stone is indicates the stain ability of the stone? Which is an indicator? The question is, which is an indicator, which character is a indicator of the stainability of the stone, whether it is going to stain or not? How you are going to find out? By conducting lot many tests in the laboratory. The workability, no, workability can't be the indicator for the stains or not. Thermal movement may not be the indicator. Toughness may not be the indicator. Water absorption, as we have discussed, more the absorption of water, the stone is more susceptible to the staining. That is water absorption. Water absorption parameter is one parameter which gives you stainability of the stone. 6th, this must be 7th one, that number has been changed. Which temperature point the igneous rocks show marked disintegration? 57.5 degrees centigrade. Up about, this answer is about which temperature point up about the igneous rock show marked disintegration? 57.5 degrees centigrade, 55.7 degrees centigrade, 157 degrees centigrade, 575 degrees centigrade. Answer is 57.5 degrees centigrade. Even your water will not boil. 55 also your water will not boil. C is a 157 degrees centigrade. It means just above the water boiling temperature. Stone will not boil. So the disintegration means stone should boil. That freezing, that heat, it means 575 degrees centigrade is the answer. So next question is, which is the scale which gives the hardness value? So we have this question 2 times here. Which is the scale which gives the hardness value? Number 1, meter scale, photometric scale, Mohs scale, and Mohs circle. So as we have discussed, meter scale is for distance measurement, photometric is for the light measurements, maybe it will not come in the hardness value. Mohs scale and Mohs scale, there are 2 different things here. Mohs circle is used for the stress in the strength of materials. Mohs circle scale is a scale which is used for the determination of the hardness value of the materials, even stone also. The next question is, stone should be free from dash. Choose among the following. That is your cavities, cracks, soft materials, all of the above. Obviously, stone should be free from cavities, stone should be free from cracks, stone should be free from soft materials. So the answer is all of the above. So thank you so much for listening patiently for so long, and we'll meet in the next session. Thank you.